Hello, everyone, and welcome to your channel of Basic Engineering. You've seen in the past few sessions, we were analyzing the truss, and we said the truss is the easiest and simplest structure we are going to encounter. Today, we are going to move to frames. Frames are, well, more complicated, of course, than trusses in the analysis, but they are simple. Over the years, I taught like this course, I know how many times. I developed a strategy that I felt worked best for my students is to go over specific steps when you solve for a frame. So sometimes we ask you to analyze the frame and find all the forces inside the frame. And sometimes we pick a member in the frame and ask you to analyze it. So what I'm going to do today is to show you how, if you are starting to um, analyze any member in a frame, what are the steps that you should take? So, analysis of frames. Step number one, you are going to count the number of unknown forces acting on the frame. Unknown, okay? Of course, if there is an external load, that's known. So we are calculating the number of unknown forces acting on the frame. Let's call this number n. If n equals 3, go ahead and analyze the member. What do you mean? Yes, remember we said a member in a frame, not usually it's not a two-force member, right? Because it's not only connected at its two ends, but it may be loaded in the middle, or else it would have been a truss. So that's why it's a rigid body, and I can write three equations of equilibrium. Last time we said it doesn't have to be summation of the forces in the x equals 0, in the y equals 0, and the moment is 0. No, I can have either the x, or the summation of the x or the y, and then moments about 2 points equals 0. Or I may have the moment about three different points equal 0 without using force equations at all. But no matter what I do, there are only three equations. So go ahead and analyze the member. Uh, on the member of the frame that you are analyzing. I'm sorry, I wrote them three forces acting on the frame. Now, on any member in a frame, in the frame. Now, and analyze the member. Of course, I can guarantee you from now, you will never start to analyze a member in a frame and you count the number of unknowns and they are exactly three, or else the problem would be trivial. So, if not, meaning if n is greater than 3, what do you do? If your member is connected to an external support, like a pin or a roller, use the overall equilibrium equations, overall equations of equilibrium, and find as many of those support reactions. Sometimes you cannot find them all, but so find as many, one, two, whatever. Subtract from n, right? Because these were among the unknown forces acting on the frame. So if this frame was connected to a roller, I could find the external support of the roller, then it's no longer an unknown, so I subtract one. If it's a pin, I subtract two. If it's both a roller and a pin, I subtract three. Okay, subtract from n if remaining number of unknowns. So remaining number of unknowns is three. Analyze. Else, if it's still more than three, then find if there's any two force member connected to your member and subtract one from the number of unknowns for each such two force member, right? Because two force member is connected by a pin. Pin is usually X and Y, but if it's a two force member, you know the direction, so it's only one unknown, not two. Okay. If remaining number, again, the remaining number of unknowns, remaining number is three, analyze. Else, if it's still more than three after all of that, so that would be a mean professor who give you a problem like that. Try to see if there's any object connected to your member. When I say object, meaning a pulley, we'll see that, or a um, rope or something, or something connected to that, and find the force acting on that object and invert it on your member. If number is three, analyze. If not, give up. If after all of that it's still more than three, then just drop the course. Engineering is not for you. You hate me, right? I shouldn't have said that. It's not politically correct. Okay. Anyway, you understand what I meant. I was just joking, okay? So here's a frame. That's a simple frame. I can see three members, member ABE, member BCD, and member CEF. Uh, I don't know which one the problem may ask you. Let's pick the one that has the most unknown. So suppose it tells you find all forces acting on member ABE. In fact, when I said there, analyze any object connected, and I said pulley or rope, sometimes it would be another member. Or a pulley or a rope or some object, okay? But when you do that, you have to remember to invert the force that you find on your member. We'll see what that means in a second. So let's say we want to find all the forces acting on member ABE. I picked ABE because we are going to go over these steps one by one. Number one, I'm going to count. We are not going to write that on our solution. I'm just showing you the way you should think. Count the number of unknown forces acting on your member. I have a pin at A, that's 2. I have a pin at B, that's 2. I have a pin at E, that's 2. So N equals 6. Is my member connected to an outside support? Yes, at A. So number 2, can you find AX and AY? In this case, you can. Why can you? Because on the other side, there is a roller, right? So if I take the moment, no, before that, you can take some of the forces in the X, you will find AX is 150 to the left, okay? And then you can take the moment about D and find AY that should be going up. So I already found 2, so now N becomes 4. Do you see what I'm saying? I will find AX and AY already. So what I need to find is BX, BY, EX, EY. 4 unknowns. Number 2, is there any two force member connected to my member? Nope. Why? Because my member is connected in the middle, this member is connected in the middle, this member is connected in the middle, so no two force members. So number 3, still N equals 4. That means I either I have to find an object connected to member ABE. Well, I have two members or two objects, BCD or CEF. So now I know I have to pick one of them and both are easy. I can pick any one of them, okay? In fact, I'm not going to do both, but we could just to show you, but I would say I'm going to pick CEF, analyze CEF. How many unknowns do I need from CEF? Only one. Only one. Notice it's connected to my member at point E. So either you find EX or EY, and we'll see which one is easier to find. That's it, basically. So after that, there would be 3 unknowns. So analyze ABE. This step doesn't exist. I don't have two force members. So now I know exactly what I'm going to do. I'm going to draw the free body diagram of the frame, free body diagram of the whole frame. Why? Because I need to find the reactions at the support A. So here I have BCD, here I have ABE, and here I have CEF. This is CEF. At F, there is 150 Newton to the right. At D, there is a roller, so dy. I have AX and AY. I assume they are positive, but I know better, okay? I also have to show the dimensions, 100 millimeters. So let's say 0.1 meter and 0.2 meters. And then the height here, 0.1, 0.1, 0.1. X, Y. So quickly, I drew the free body diagram. Now I have everything I need. I'm going to say, so let's start the analysis by saying summation of the force in the X equals 0, right is positive for the whole frame. I don't have anything other than 150 going to the right and AX going to the right equals 0. So AX equals negative 150 Newton equals 150 Newton to the left. Okay. Now I can take the moment about point D or even about point A, find dy and then find AY. It's the same thing. taking the moment, summation of the moment about d equals 0 counterclockwise is positive. This one is going clockwise, so negative 150 times 0.2. AX, which is now pointing to the left, so minus another 150. Notice 150 times 0.1, that's the perpendicular distance, minus AY, because it's also rotating clockwise, times 0.3. Notice this is 150 times 0.3 when you add them up. So if you simplify 0.3 and 0.3, you get AY equals negative 150 Newton equals 150 Newton going down. So this is going down, this is going up. They are rotating counterclockwise. The magnitude is 150 times 0.3. And this is going to the right, this is going to the left. So it's rotating clockwise, 150 times 0.3. These are the two couples that they are equal and opposite acting on the frame. So now I'm done with that. I'm down here. I need to analyze. I didn't have, I'm sorry. So I already did the two support reactions. So I have four unknowns. I need one more. We don't have two force members, so we skipped number three. Step number four, we could have picked this or that. We just decided to pick CEF. So free body diagram of CEF. Here is CEF. At C, I have CX and CY. At F, I don't have a support. I only have an external load of 150 Newton. At E, I have an EX and an EY. And this is 100, 100, or 0.1, 0.1. And there is nothing else. It's just the vertical element. So easy. Notice I need one of these two. There is no force. I cannot use summation of the force in the X because I have two unknowns. Summation of the force in the Y, I have two unknowns. But if I take the moment about C, notice that EY is along the line of action, so it doesn't produce moment about that. These two intersect here, they do not produce moment. And I say summation of the moment about C equals 0. This is positive. I have 150 rotating clockwise, so negative 150 times 0.2. And I have EX is also rotating clockwise, so minus EX times 0.1 equals 0. Of course, if you solve, you will get EX equals negative 300, right? 0.1 and 0.2 would make that 1 and 2. 2 times 150 is 300. So negative EX equals 300, or EX equals negative 300 Newton equals 300 Newton to the right. And here is where most students who lose points make the mistakes. Let's do the free body diagram. Oh, I'm sorry, here I missed something since, well, I didn't miss anything. Remember, we didn't use summation of the forces in the X equals 0 or summation of the forces in the Y equals 0, so I'm not required to show my X and Y. However, some technical people will say, oh, but you wrote EX and EY. So just to be on the safe side, I'm going, okay, here's my X and Y if it makes a big difference for you, but it doesn't for me. Free body diagram of my member ABEL. Finally, because I'm done with that, and now I have three unknowns, and it's three. So I can analyze ABE. Here is ABE. Oh, I'm sorry. B. I have BX and BY. And at A, I already found AY is going down 150 and AX is going to the left 150. Now EX and EY. I already found EX. Here is the most important thing. I found EX that is acting on member CEF and it's pointing to the right. There is another EX. Notice at EX there is a pin. And inside the pin there are two equal and opposite EXs, one acting on this member and one acting on that member. We found the one acting on this member is 300 Newton to the right. So the one acting on member ABE, my member ABE, is acting to the left and it's 300 Newton. Many students take this and draw it the same way. Now, that means you have two EXs pointing to the right and your frame would move and tumble clockwise. I mean, it would turn, which is impossible if it's in equilibrium, right? Again, here is my X, here is my Y. And I have 100, so 0.1 meter, 0.1 meter, and 0.1 meter. Notice I have also an unknown reaction, EY. We never found EY, right? We didn't need to. And here you have three unknowns. I can start with the summation of the forces in the X because I know the 300, I know the 150, the only unknown is BX. So we can say summation of the forces in the X equals 0. I have BX to the right, minus 150 to the left, minus 300 to the left, equals 0. And this is positive. BX equals 450 Newton to the right. Then I'm going to take the moment either about E, because the only unknown is BY, or about B, because the only unknown would be EY. It really doesn't matter. So let's say we take the summation of the moment about point B, equate that to 0. This is positive. Take the moment here. This force, and that force, all these three pass through B so they don't produce moment. You have three forces producing moment. The 300 is rotating counterclockwise, so that's positive 300 times 0.1. You have negative 150 times 0.1. And you have positive EY times 0.1. Notice you can simplify by 0.1, 0.1, 0.1, and you get we said this is negative this. Okay, so you said this equal 0. So EY 300 minus 150 is 150. So EY plus 150 equals 0. EY equals negative 150 Newton equals 150 Newton down. And finally, I do summation of the forces in the Y equals 0. Up is positive. I have negative 150. I have BY, which I don't know what it is, so plus BY. I have EY going down. Remember, we found it to be going down, so minus 150. Anything else? Nothing else. Equals 0. So BY equals 300 Newton positive, meaning we drew it correctly, it's upward. So we found AX, AY, BX, BY, EX, EY. We found all the forces in the frame, but after following these 5 steps. Okay, now sometimes they ask you to find the force as a magnitude and direction. So you can take the square root of 300 squared plus 450 squared. That's the force at B. And it has a slope of 3 over or 2/3. So you can find this angle. Also, for A, you have that in the third quadrant. and it makes an angle of 45 degrees because it's 150, 150, and the equation would be the square root of 150 square plus 150 square. For here, if you want you have ex to the left and ey down 150, so it's here in the third quadrant. And the magnitude is square root of 150 square plus 300 square, and the slope that it makes is 1/2. So you take the inverse tan of 1/2 to find the angle. But generally, if you find x and y, that's good enough. And that is how we analyze this frame. Okay, I have another one for you, and that would conclude the topic of frame analysis. Here's another frame. And in this case, they want you to find all the forces to, meaning analyze member AG or ABCD. I just added uh, the letter G here because I had A through F. So A, G, B, C, D. Let's count the number of unknowns. This is a roller, so that's one. C is a pin, so add two. B is a pin, add two. G is a cable, add one. And A is a pin, add two. N equals 8. I have 8 unknowns acting here. Step number 1. Step number 2. If this member is connected to external support, yes, in fact, it's connected to 2 of them. I have AX, AY, and DX. Okay? So if I take the moment here, I can find DX. Sum of the forces in the X equals 0, I get AX. And sum of the forces in the Y equals 0, I get AY. So I can find 3 of them. So step number 2, N became 5. Step number 3, is my member connected to a two-force member? I just showed you that by drawing this beforehand. This is a two-force member. It's connected at C, it's connected at E, which are the two ends, and there is no load between C and E. So the force in CE is along this line. It's only one unknown, so now N equals 4. Is there any object connected to my member? Yes, there is a cable. That's a smooth pulley. So the weight here, this is a mass, by the way, not a weight. But the weight pulling down is the same as the weight pulling to the right because that's a smooth pulley. So I can find this force. So N would be 3. And finally, I go to my member. Let's call it ABCD. So now we know our work. First, we are going to find the out the support reaction. So let's redraw the frame. So to save space, I'm going to redraw it here. I have A, B, C, D. At D, there is DX. Here is C. So there is member CE. This point is B. That point is F. I have a pulley, a cable. This cable is going down. And this is AX, AY. Notice, I only see DX, AX, and AY. I don't see BX and BY and all of that because these are internal forces. I only see what's outside and any external force that exists. 1.5, 1.5, 0.5, 1.5. And here I get, well, I drew this longer, but this is 2 and this is 3 meters. Again, the important thing is the numbers, not the scale. We don't waste our time to draw it to scale. Okay, so from here, first of all, I find the weight. Okay, so let's find the weight first. We know we are going to use 400 kilogram and multiply it by 9.8. So this is 3920 Newton. Okay, just multiply by 9.8. So when I start, I say summation of the forces in the y equals 0. Why? Because the AY is the only vertical support reaction. There is nothing else, right? So up is positive. I have AY going up minus 3920 going down. So AY equals 3920 Newton going up. That was easy. I found that. In fact, some people would say, I don't need really to say, take the moment about another point and take the summation of the forces in the X. How else can I solve this problem? If you learned couples properly, you would say that the 3920 and the 3920 going up here is a clockwise couple, and its magnitude is 3920 times the perpendicular distance, which is 5, right? So dx and ax should produce a counterclockwise couple, meaning I know for sure that ax would be going to the left. Why? These two forces are rotating clockwise, so those two forces should rotate counterclockwise. It turns out that if you add 1.5 and 1.5, that's 3. 1.5 and zero point 0.5 is 2. 3 and 2 is 5. 3 and 2 is 5. It's the same distance. So I know this is 3920 to the left. This is 3920 to the right. Again, we are saving time, but you have to show your work in a course, right? I'm just showing you that we know the answer before saying summation of the forces or summation of the y, just because we were lucky. The distance between these two forces, ax and ay, was the same as the distance between these two forces. One of them is rotated, one system, a couple is rotating clockwise, so that other couple should rotate counterclockwise and it should have the same magnitude. So now I have 5 unknowns. I solve for 3. Oh, but I know that CE is a two-force member. So when I draw the free body diagram of ABCD, I'm not going to say CX and CY. No, I'm going to make a line in this direction. Notice this height is 1.5 and this base is 3. So the slope is like 2 to 1 to root 5. We'll do that later. But now I know that it's a 4. I subtract 1. It tells you subtract 1 for every two force member connected to your member. And now I need to find any other object connected. Excuse me. The object that I have is a tension. So I can replace that with a force of 3920 pulling to the right, and that's it. So now I move directly and say free body diagram of member ABCD. Okay, so it's just a vertical line. Let's draw it of length 5, since we know there is 1.5, 1.5, 0.5, and 1.5. At the bottom at point D, I have 3920 Newton going to the right. At point C, I have a force, a two-force member, like a member in a truss, that I'm going to call CE. Oh, Yeah, CE. At B, I have two unknown forces, Bx, By. Here, I have a tension of 3920 going to the right. Okay? And then at the top, AX and AY, there is 3920 to the left and 3920 going up. Here are the distances. 1.5 meter, 1.5 meter, 0.5 meter. Why did we say 0.5? Because they tell you the radius of this pulley is 0.5. So if the radius is 0.5, then that distance between the center line of the pulley and the edge or the cable is 0.5. And finally, 1.5 meter. Here is my X, here is my Y. It looks complicated, right? But when you go step by step, you see that we only have three unknown forces here. I would prefer to take the moment about point C, while many students will take it about point B. Because they tell you, oh, there are two forces intersecting here, so when I take the moment, I can find C. But C is inclined, right? If you take the moment about C, By also passes through C. So the moment about C will have only one unknown. So let's take in fact we could have started also, yeah, we have it, taking the moment about C is the easiest, I believe. Okay, so now how many forces rotate about C? I have this guy, this guy, this guy, and that guy. Four things. Notice that these two form a couple. So I can multiply 3920 by the distance, which is 3.5, and that's it. I don't have to say this times that and this times that. If it's confusing to you, it shouldn't be, because we said couples, the moment produced by couples are free moments you can play. If you take the moment about C, they have a magnitude. If you take the moment about A, they have the same magnitude. If you take the moment about B, it's the same magnitude. However, because I don't want to confuse you here, I'm going to say take the moment about C. So this rotate counterclockwise, 3920 times I'm taking the moment about C. So the distance is 1.5. 3920 is rotating clockwise, so that's a negative. So minus 3920 times 2, 1.5 plus zero point 0.5. Oh, I was talking about these two are couples, or these two, not those two. I thought I mentioned these two. No, of course, these are not couple. Both of them are to the right. So D and A, AX and DX is a couple, or the tension here and AX. You can use those anywhere. Anyway, so I'm taking the moment here. So I still have 3920 is positive, rotating about C, and that distance is 1.5, 3.5. Okay? And finally, I have Bx rotating clockwise, a distance of 1.5, 1 minus 1.5 Bx equals 0. So really, when you add, if you take 3920 as a common factor, you get 1.5 minus 2 is negative 0.5 plus 3.5 is times 3. So 3920 times 3, when you move this to the other side, it becomes positive 1.5, and you divide by 1.5 to get Bx. Or just do the math and you will get Bx is twice as much as that, is 7840 Newton. Positive meaning it is to the right. So we found that. Notice that CE here has a slope of 3 and 1.5, meaning 1 to 2, meaning vertical is 1, the slope is 1/2. Horizontal is 2, right? 1.5, 3 is the same as 1, 2, so this would be √5. I can take, say, the summation of the forces in the x equals 0. So I have negative 3920, positive 3920, they cancel each other. Then another plus 3920. These two cancel, of course, as we know. And then I have 2 over √5 plus 2 over √5 CE equals 0. So CE is negative. CE is compressed, of course. That makes sense. And its magnitude is 3920 √5 over 2. 4382.7 Newton compression, meaning negative, or it's 4382.7 Newton in the opposite direction, meaning it has a direction like that, and you can say 2, 1 like that, or 2, 1 √5. This is the direction of the force CE. The only thing remaining is By, so I take summation of the forces in the y equals 0. I have 1 over, notice this is going down now, okay? So it's negative CE, 1 over √5 CE, that's going down, plus By, which we are looking for, plus 3920 equals 0. So By equals, I'm going to take that as positive and that as negative because they move to the other side. So I'm going to take this number divided by the square root of 5, right? 1 over square root of 5, but that would be positive, and then I'm going to subtract 3920, so I get negative 1960 Newton equals 1960 Newton down. And I found all the forces acting on member ABCD. At D, there is dx, and dx, we said it was positive, it's to the right, so I have to show that. At C, there is a force of magnitude 4382 pushing down on this pin. Then at B, I have bx to the right and by down. Here there is the tension. At A, I have ax to the left and ay up. And these are all the forces acting on the member. But instead of trying to waste time, where should I start? What do I do? Follow these 4 steps. And if you don't reach 3 at the end, it means your original frame was statically indeterminate, and you wouldn't get a problem in statics using statically indeterminate. You must have missed something. Maybe there was a 2-force member that you used X and Y for it, don't realizing that it's a 2-force member. Maybe there was a pulley attached to your member or a cable, and you thought you don't know its magnitude, while this magnitude was easy. Like in this case, we know this force is the same as this tension. In fact, I don't want to say, let's draw the free body diagram of the pulley. Here is the pulley. It's at point F, there is an Fx and an Fy. There is a load coming here of 3920 Newton, so there must be another load of 3920 here. These are the loads acting on the pulley. So Fx here is 39 from summation of the force in the x equals 0, and this one is 39, 20, like that. If you are analyzing member BEF, you would invert these two and you say Fy is going down 3920 and Fx is going to the left 3920. This is a two force member and there is a Bx and a By. If you take the moment about C, you will get Bx and By. So I could have also analyzed this member to find Bx and By and the force C. But there is no one way to solve, just one way. If you see that you can find some of the unknowns from another member, be my guest and analyze that member. But generally speaking, it was easy just to concentrate on the member we have and say, okay, I can find these three reactions. The 8 becomes 5. This is a two force member, so I subtract 1. Now they are only really 4. This thing is going all the way here. So the tension, you can see that if you pull here, it's the same pull if the pulley is smooth. If the pulley isn't smooth, you wouldn't know the force no matter what you do because we haven't given you any more information and we haven't covered friction yet. We will cover it later, and that probably would be the last topic of the course. Before that, we'll do machines. Machines are very similar to frames. The only difference is that machines are designed to produce work, so there is motion in it, right? Say motion, this is a course in statics. Yeah, we know that. But we are saying is I'm not having supports keeping things in place. There is motion to produce work, but when we analyze a specific scenario or a special snapshot, and we see what are the forces that this instant acting on the machine. We'll see that next time. And until then, I wish you all the best and hope to see you soon. Bye.